Is OBS going to behave today? We got here bright and early. All right, we clicked all the buttons. Hopefully we hit it the right way. Does this work for my amazing 4 slides? It appears to. All right. As far as I'm aware, today's September 10th, 2024. We're here on our 4th week of CSE466. We're talking about reverse engineering. So I'm going to stop posting these type of memes or sharing them. All right, the doom and gloom is over. All right, I get that it's rough, but we've left the station. I might still give you credit, right? Like I might still give you the liked meme, but hopefully we can move away from that direction. So we've been kind of struggling with YON 85 for those that started it. A couple strategies that people have come to realize. I may be able to solve the 0.01 because it's going to print out a whole bunch of help text for me. I get to the 0.1, turns out I really had no idea what was going on. We go back and look at the 0.0. Not only because of the nice help text, but as I mentioned at the beginning of this module, the 0.0 has symbols, the 0.1 does not. So it's definitely a lot easier to look at the 0.0. So definitely a strategy here. This one kind of scares me for a number of reasons. It says my Excel sheet I used to keep track of the YON code, and then the actual YON code, and they're different. It scares me not only because they are like different, but the fact that you're using Excel to track this. If it works for you, like it works for you, but I would strongly encourage finding a better workflow. And on that note of just like how to make sense of this, I heard, and I have personally seen, some people kind of writing stuff out by hand on pen and paper. That's totally reasonable. And like I do that when I'm thinking about high level things, but we shouldn't be having to do that for reverse engineering purposes. Hopefully today's demo will show you how we can leverage these tools instead of just me stating how we can use them. And eventually, if you stare at YON 85 enough, it starts to make sense. You find the parallels between the YON 85 instructions and how you know an x86 CPU works. And that hopefully means that you can now read it when that help text is printed out. Other memes. So this weekend was kind of a freebie, right? Because we had that deadline pushed. How people decided to use it, up to you. YON 85 still waiting for you. So for those students that still haven't started, might want to think about it. I really liked this meme. I can't read it from the slide, but I know exactly what it's talking about. So he's probably thinking about other women. No, what is he actually thinking about? Why isn't my brute force working? Maybe my value for register I is wrong and the instruction pointer isn't actually incrementing. That could explain why I'm hitting the bad instruction instead of the infinite loop. And I need to account for timeouts so I can ensure I'm testing all possible values. Maybe I'll just start this all over again in the morning. So for those of you that haven't gotten there, which I believe is most of the class, level 22 asks you to pass in your own YON code, which is one of the things that having an assembler would help you on. But particularly 22.1, it doesn't print out anything. And that means that you have to figure out what is the encoding dynamically based on the behavior. I'm going to tell you right now that the encoding for 22.1 is seated on the flag. And what that means is that if on 22.1 you are starting it up in practice mode and figuring out what is the encoding, that will not be true in the challenge mode where you can actually get the flag. Right? So don't, for 22.1, you end up having to do this type of reasoning here, which was one of the questions that I got before the stream started. It was, hey, for 22, how do I kind of figure out what's going on? And the answer is to do exactly that. You should have some idea of what the permutations of these bytes could be. And so you will have to write some type of rudimentary fuzzer, which is just going to generate these bytes and kind of throw it in and see what happens inside the challenge. You can't GDB attach it. You can't inspect it internally. It's just, okay, did this thing run? Did it exit? Did it crash? Did it seg fault? Did it hang? Did the exit code change, right? Like what few things can you observe? And then based upon some combination, you'll notice a different behavior of the program, which then informs you about either like the byte order or the meaning of specific bytes. It sounds like a lot, but once you have kind of caught the edge cases that can blow up your for loop, you can start figuring out most of the instructions to where you can pull it off. But in the immediate, you definitely end up in kind of this weird position because you're like, well, what's the next thing that I can infer given the prior thing? Which is the state of that person. But when you do solve things, all right, it feels good. That's good. How are we doing so far? So I'm only counting, and I'm just going to do this for the course going forward. I'm only counting people that have solved at least one challenge, right? If you haven't solved anything, I don't know what to tell you. Right now, those people are at about 64% of the material, which is awesome, right? We're halfway through, you're halfway there. I didn't, the checkpoint going away didn't destroy the average there. From what I've heard, most people are stuck on either. I should capitalize both of those. That's what I get, man. I make these slides a little bit before class, as you could imagine, so I can get your memes. And then I get interrupted and end up with lowercase l's. Is this accurate? Is anyone like not stuck here? All right, so that means that this will be somewhat relevant. For Twitch, literally nobody raised their hand. So everyone is stuck on one of these two problems, which is a good sign. If you have something specific that you want me to do, well, we'll definitely bang that first. Otherwise, I want to use 17.0 and 17.1 as kind of a straw man here. I'm hopefully not going to solve it, but it may accidentally happen because that sometimes happens when you're working on real challenges. I want to show how we can use GDB scripting to dynamically kind of make 17.1 equivalent to 17.0. It's one of my favorite things that I've ever demoed on pwn.college, and then the original video got pulled, which was a shame. And then I want to use IDA a little bit on 17.0. Again, how can we make 17.0 look like 17.1? And then for these people that are writing stuff out by hand, my understanding of what people were writing, somebody says they're on 20. I have no idea what the subproblem in 20 is, but if you're like hard stuck, freeze, conceptual problem at me, I'll see what I can do. For people that are hard writing stuff out, what I had heard is that we're writing like, okay, we're going to AND this with that, and then we write the value, and we're like doing this math by hand. If we're doing that, that's a really long way of doing things. If you took 365 reverse engineering, you probably used Python to reverse your manglers. Does anyone recall doing that? Okay, less than I would have thought. So we'll hopefully get some time to hit on using that instead of writing the stuff out by hand. Does anyone have anything specific you want me to hit, or is this a good roadmap for the next 45 minutes? I got a thumbs up. All right. Cool. Let's see what we got here. Twitch says GDB scripting. Yeah, that's the plan. I didn't dry run this, so the demo could go awry. So that's 19. I said I was going to look at 17. Let's fix that. All right. So I'm here in 17.0. At this point, you probably have figured out how to interpret this. Is that fair? We have some idea of what like IMMB equals 72 is? Is that a cool? And so we see, for instance, this sys hex 20A. And then we see read memory. What can we infer from this right here? Right, we're performing the interpret sys, and then the byte that's being used to represent the read is probably hex 20. I don't know this for sure, but I'm willing to bet that's what's going on. and then the result goes out in A, if I remember, as far as how the interpret sys works. We type in some nonsense. It prints out a whole bunch more stuff. And then it says, doesn't it say incorrect? Did I miss it? Call right.
It says on the left, like one. No, it's like one character.
I'm sorry?
Oh, yeah. What? It says on the left, one letter each. One character.
Oh, yeah. Okay. Sys right RROC. Yeah. So it has this right. Why am I getting that behavior? Yeah.
For now, it's just like printing one character using its own syscall.
Okay. So for right now, the Yon 85 implementation can only print out one character at a time when it uses its internal syscall. Yeah. Is that? That's what we got. Well, I'll go with it. Makes sense to me. Okay. So we're going to open this guy up in IDA, or not IDA. Yeah, all right, let's use IDA. And this is just going to be a quick review before I hop to 17.1. We mash tab. Because there isn't a need to do a lot of like reversing, renaming stuff, retyping stuff in the 0.0 challenges since they have symbols, right? IDA is not happy with me. Okay. So we're inside of main. There's an execute program function. And what we'll see here is because these have symbols, we can see the function names are, for instance, interpret immediate, interpret sys, etc. So it very much maps what we saw when we ran the challenge itself. Right? We see how this kind of pairs one-to-one. Now, what I want to do, just out of curiosity, how many are stuck on 17.0? No hands. How many stuck are on 17.1? No hands. Nobody stuck on 17. Is everyone really on 19? 19's just right at disassembler, guys. Come on. All right. I'm still going to do this. So what I want to do is I want to turn 17.1 into 17.0. I think this will still have value even if you're not stuck on this challenge, just from a GDB scripting usefulness standpoint here. Now, if I want to create something that prints out these bytes, where in the process am I interested in breaking? Like, I want to know when does, for instance, immediate D equals 43. I want to display that, not using the challenge, but using GDB. What point of execution am I interested in? Nobody knows. So right here, it would be interpret immediate. So if I set a breakpoint at interpret immediate, GDB scripting, doesn't need to be named .gdb. I just opened a file called do.gdb. You can do it inline in Python too, doesn't matter. I can set a breakpoint there, and then you can do this thing called commands. Commands allows you to specify what happens automatically at that breakpoint. Why is this useful? Well, I could printf calling interpret immediate and then continue. And then I'm going to include, I don't need that continue there. So if I have that, if I'm just using GDB on the terminal, it's -x. I'll give it do.gdb and then the challenge. Everything is ruined and it's over. What did did we get? Okay, we hit the breakpoint. This is one of those shenanigans. This is why you dry run your demos. All right, PSAUX, script GDB, kill 1641. I'm going to blame Jeff. I don't know that that's actually the problem here. That still didn't kill it. Okay, let's kill 1455. All right, let's aggressively kill. I don't know what I've done over there, but it is not happy. Let's try it again. Let's do it in a different window. GDB-X do.gdb. Okay, I set the breakpoint. We run it, and we see what happened here is now every time that we hit this interpret immediate, this is even outside of the challenge doing it, we see calling interpret immediate, and then since I didn't include a new line, I'm functionally equivalent with what the challenge does on its own, right? Now, the other thing I may want to include now is, well, what register is being set. So I'm trying to emulate this in line, right? And this seems a little bit silly because right now I'm printing out exactly what the challenge does already. But let's keep driving there. How do I get the equivalent of this right here, whether it's A and then what the constant is? None of you did this cool dynamic GDB scripting stuff for 17. You just solved it. So we could look at interpret immediate, and we see the arguments here in IDA. This is going to correspond to RDI, RSI, RDX. It's the same calling conventions we hopefully are already familiar with. So what register, this one is nice because it prints it off, is going to hold the byte that is the register. So this has this nice described register function, which is taking that byte and then mapping it to a letter visual representation of it. But let's assume we won't have that because we won't have that in point one. So it's A2. A2 has the byte here that represents the register that's going to be used. And so what register do I want to print out? RSI. RSI sounds right. So let's go back to our script here. I'm going to set a variable. We're going to call this reg, because why not? And we're going to set that equal to RSI. Inside my, what do I want here? I'm going to go with ULLX. Inside my printf, I update my format string, so I have something like %ULLX, which maybe will yell at me, maybe not. In theory, that's an unsigned long represented as hexadecimal. I have a comma, and then I have the value that I want to display. We give that a go. Did I get it? I think so. So here, it didn't deal with, it just went with U, it's just like an unsigned. And it treated LLX as characters. But we still see here that B is corresponding to 1, C is corresponding to 2, A is corresponding to 4. I can reasonably infer that even if I can't properly write format strings. The other value that I'm interested in here is what is the constant, right? From the challenge output, it also shows this constant. Where can we infer that's coming from? So this A3, which is the third argument. So it's going to be register RDX. Now, in my script here, I could literally use RSI and RDX, but I think it's a little bit more clear if I try and name these. Okay, does that look pretty similar here? I still haven't added the space or new line, but we can map it to a C. We see the 6 here, we see the 6 here, we see the 72 there, there's the 72 there, because I went LLX here, so this is actually hexadecimal, I just didn't prefix it with 0x. But we see that we can replicate that, that output. You're like, well, that's great, but this challenge had it already. So why do I care? Well, if we fire up 17.1, now that we have some idea of how this thing behaves, I can't use the exact same script, because my original script here relied on that interpret immediate symbol. And if we look at 17.1, IDA will just yell at me again. We can go into main here, and then we don't have any symbols. What can we assume this is, knowing that these are similar? Somebody said execute. I think it's execute program. Is that right? So I put my cursor on this thing. I hit N. It says execute program. We mash enter. Now this looks more similar to what we had in 17.0. Are people doing this when they're using IDA? Yes? Okay. I heard something to the contrary and it scared me. Okay. This instruction right here. Do I know what it is right now? You do? I mean, we could guess. I don't know what it is. What are you going to infer? Like, I'm not going to. I think your logic will be good.
I don't know.
Just because it's the first couple things, and the first couple things we have to throw some constant somewhere.
When I was solving it, I think I also knew that IMM was one of the most common functions.
Okay. So the statement for Twitch was, I think this is IMM. I think it's IMM because it's fairly common. IMM is one of the most common instructions we've seen when we're looking at this Yon code. And I tacked on, I don't know if the student agreed or disagreed, that logically the first couple things you have to do is like have some values somewhere, right? And so that's a reasonable like heuristic thought. If we click into it, we see it's just a wrapper for sub 1323. Well, that doesn't really help me do anything. Okay. If we go into sub 1323, I get this. Does this look like what an immediate looks like? Some people are saying yes.
Actually, it looks like the register.
Okay, so it does say undone register down here at the bottom, so that's a good clue.
Yeah.
Now, the active reversing is doing that inferring, right? And now it does make sense. So this is probably like set register. Now, I don't know what A1, A2, A3 is yet. What do we think it is? So I'm going to leave A1 alone, and we're going to just look at A2. A2 is interesting because there's this switch logic on it. What is different here based upon the switch? Because there's like a pattern. What is A2 influencing?
Where in memory is stored.
The statement's where in memory is it stored? And that's absolutely correct. The only thing that is different between case 32 and case 2 is what is the offset from A1 where this value is being stored. So we could infer A2 mash n. We're going to call this the register byte. You call it whatever you want. So what does that mean A3 probably is? The value. So we mash n over here on A3, and we get the value. This looks a lot more sane, and it looks a lot more like what we had in 17.0. There was the meme that said, hey, I was looking at the 0.1, now I'm confused, I hop back to 0.0 to reference it. You can do that, or you can think about, how would I implement this, and then what do I see, and clean up what you are actually dealing with. So if this is set register, and that is a constant, then we inferred that this was immediate. Then we map from here to here. We have the register byte, then the val, and if we go back up to here, this is our register byte. And then this is our val. Does anyone know what this A1 is? Is it? Okay, the statement was it's a memory location, and that's assuming IDA is correct, which I don't think IDA would mess this up. IDA is saying that it is a byte pointer. It is a pointer to a byte, and that is all IDA knows. So it is a literal memory address inside the process. But what purpose does it serve in the context of this Yarn 85 CPU? Anyone else? Yeah?
Like memory.
Okay, so the statement was, is it memory? So it could be, right? And so we could call this the Yarn 85 memory. That's what we think it is right now, right? And when you're reverse engineering, it's totally reasonable when you have that kind of first inkling of, hey, this is what I think it is. Call it what you think it is. Even if it's wrong, what this will do for us, hopefully, is we'll see this variable name pop up somewhere else where it may not make sense. Well, if this was the Yarn 85 memory, why are we doing XYZ to it? Did that populate down? No. Just for completeness. Oh, I hit Y instead of N. Yarn 85 memory. Cool. Go back up. Bam, bam. All right, so now I have my immediate here, and you could envision that we're doing the same thing for all of these functions, right? But we still, right now, we think this A1 is, don't hit Y, hit N, Yarn 85 memory. Why is this Yarn 85 memory passed into everything? In fact, we said this is an immediate, right? Like our first instruction that we did successfully decode, it's setting a register inside the context of the Yarn 85 CPU. So why does it need this pointer? Anyone other than you? I'm just trying to get some more reach here. What are we thinking?
Sets aside a frame for everything in the program to affect memory.
So the statement was, I think it's a frame that like represents the state of the program in memory. You're not far off. We need to think about how is this thing being used. So clearly somewhere here, at an offset from this Yarn 85 memory, is the emulator's representation of registers, right? It's kind of interesting and completely not accidental that where do these registers begin? 256. So this is where I would draw something. I know I didn't set up, I got here 20 minutes early and didn't set up my fancy drawing stuff. Bam. Hit my watch before the screen. We can think of this Yarn 85 memory. We actually know something about this, right? We know where the registers or the implementation of the registers are relative to this pointer. We know that 256 bytes after that address is where the registers exist in memory. But what's happening before that? Like, we could actually think of this like it's some kind of struct. Everyone know what a struct is when I say C struct? Cool. It's just some region of memory where like the types are tightly packed and well defined. And so we could define this as a struct. I don't know how to define structs in IDA. I know how to do it in binary ninja, but not in IDA. But we could define this instead of being a byte pointer. We could define a struct and say, I know that this is a pointer to a struct that has 256 byte character array, because I know that exists before this. And then there is I have to hit tab here. We see that it's moving a literal byte. So there's a 256 byte character array. Then there is a byte representing this register. There's a byte representing that register. There's a byte, et cetera, right? We can encode that. Oh, all right, Twitch, you want to drive? Shift F1. This sounds like danger. Local types. All right. Insert new type dex. Okay. Struct, yon struct. I want this to be, I'm assuming this is, I don't know. I'm just going to call this buff at 256. And then I'm going to have some char that is reg 1, char reg 2. Anyone know how many registers there are in this thing? A, B, C, D, S. That's it? All right. Bad declaration. Oh, that wasn't fun. Oh, I didn't terminate these. We'll learn something together here live. Boom. All right. So now yon struct exists. Thank you for that, Twitch. So now over here, I should be able to hit Y on my yon 85 memory and say this is a yon struct. You think it'll make me say struct yon struct? Let's find out. Oh, so now we have typed it as a complex type. We said, I don't know, man, there's this yon struct thing. And so far, the only thing I know about it is that there's 256 bytes before it, right? And then starting here is registers. And I don't know that these are ADC, they could be, right? And so I'm just going to name them as something that works for me. And now this suddenly looks a little bit cleaner. It has a lot more semantic information. Now, odds are that didn't populate back up. Oh, it did? No, it didn't. Bad declaration. Yon 85. What?
No 85.
Oh, it's just yon struct. Thank you. Is it going to pass that down now? It is. So it won't populate up, but it looks like it will pass it on down into this new thing. And so now that I'm looking at this other unknown function, hopefully A1, I now am looking at something that is interacting with this unknown buff. And so I said that reg 1 was a char, because I know a char is a byte. And I was casting this as an int 8. Well, that's kind of ugly. Can I go in here? Can I edit it? Oh, we can. Let's just sanity check that. And if you do this, not only with structs, but you do this across a binary, you can turn your pseudocode here into something that becomes much more readable. Or your decomp. Did that not? That didn't populate down. It's still casting it. Oh, it's because I said it was unsigned, or I didn't say it was unsigned. So it's still doing that. Like the decompilers can be very picky about the types and the casts. That's how you get ugly. I'm not going to spend more time there, but you can envision that I did unsigned in 8. This goes away. And what we see now is for whatever function I happen to be in, it is calling open on the address of buff, which we defined as the beginning of that Yon85 memory thing, indexed at whatever is in register 1. And then the second argument to open is whatever is in register 2. The third argument is whatever happens to be in register 3. Is that more clear than what you had before coming out of IDA? And someone says, that makes more sense. Yeah, it turns out decomp, like, and IDA is the best, I said last week, at initially hitting tab and getting something sensible. But you see how just providing a little bit of type information can make this surface and hopefully become a lot more understandable. All right. So that was my little IDA detour. Let's go back to where I started, which was this GDB script. Because now we're over here in 17.1. And when I run 17.1, I don't get that pretty help out. But when I was in 17.1, I started on my GDB script here. Now, this isn't going to work if I were to GDB it. Because it says there's no symbols, and so it doesn't know where to set that breakpoint. I talked about this last week, but we're going to see if you guys retained it. How can I deal with that?
Yeah, you can get address.
I can get the address. How am I going to do that?
At the bottom, I think it should.
So this right here says 3121. Is that what I want?
It's better to go into assembly, and from there you can find the address of it. So you can do object dump.
Okay, I could do object dump. Object dump D challenge whatever. And this will give me some information, except that is AT&T syntax, which is horrible. So we dash M Intel, and then let's pipe that into less. What am I looking for here in object dump? How do I know where I am? Because this is if it was a 0.0,
Okay, this is the strip.
this would have symbols, right? I'd see like main, right? We would expect main to be there. If it was a 0.0, object dump would have that. You're accurate. But since this is not, this binary doesn't have symbols, I'm kind of at a loss as far as where do I actually want to be, right? I do get these address points, but I don't have that contextual information to know how it relates to what I'm trying to do. And what I'm trying to do right now is just find where immediate is. And so I could be right here. Right now, I'm up in main. Drive me. Where am I going? Tab. I'm still in main. Is that where I want to be?
Execute program.
Okay, so I'm going to double click instead. I'm going to tab back. We're going to execute program.
And click on IM.
Okay, click on IMM. Double click. All right, double click. We're in there.
Double click here again.
You want to go into set register?
We want to know what's opcode.
So at this point, it doesn't necessarily matter, and that's because we can see here that the arguments, since we've done a little bit of digging here in IDA, the arguments are the same. So whether I set a breakpoint here, where set register is called, or I go into set register and set a breakpoint inside of that, I should still be able to access the same values, right? So we'll stop here. And when I have my cursor on set register, we see 1464. But as was noted, don't trust that. Hit tab and go back because we want to find the literal instruction, right? If IDA for whatever reason gave me, what is this, 1469, it would be after the point I'm actually interested in. So tab back, get the level of detail you want. 1464 is correct here. So at this point of execution, what we see in the assembly instructions above are those values being set in RDI, ESI, and then there should be one more. RDI, RSI, okay, it's all the way up there. And EDX. So I have that. How do I use that information to inform me of my GDB script? Okay, I'm going to copy it to temp. And then I can use base, which again is this magic constant I have hiding inside my GDB init. I'll throw it on the screen here in case anyone missed it. If GDB is debugging a non-setuid binary, that will be the beginning of where the ELF is loaded into memory. And so we're taking advantage of that. And what was our magic number? 1464. So we'll say OX 1464. And hopefully, if we did everything right here, it does not look like I did everything right here. What's that? Something. Oh, yeah. Okay. Good point. Good call. Good call. I did the obvious bonehead where I copied it to temp, but I wasn't debugging my copy. So if we debug the copy instead, all of a sudden I get very similar looking output to that help text. Now, when I have unlimited time, the original demo of me doing this, I did this for every single function, right? And you can envision writing a GDB script that does that. Because what's going on here, the registers that you're accessing are always going to be, because of the way these functions are similar in IDA, RDI is always going to be this pointer, RSI is always going to be this second argument, and then RDX is going to be the third argument. So we have this consistent pattern, and so we can do this same type of thing. We can even define this as a function in GDB, and then just set our breakpoint, call the function that's going to print it out and make it pretty. And so you can build upon this to turn 17.1 into 17.0. Does it matter that if I encode, like for my reasoning purposes, this register is A or B? They're just some register, right? If I wanted to map this to a character, I could write some little if thing and make it print out a prettier letter, but I don't care, right? If I know this is my representation of the register, then that's great. If I see 2 down again, then 2 is just how I'm reasoning about the register, right? And using numbers instead of letters. Let's double check Twitch here. Twitch says uint8_t. I'm giving up on types, all right? GDB is the way. Now, these challenges, as far as this Python point on the slides here, how to leverage Python to anti-mangle or demangle something. If I were to continue my quest here in IDA, what we'd see is that these operations, which are definitely more visible in the 0.0, are somehow manipulating my input or manipulating the value that's being compared. But I don't necessarily know how right now. Once I have an idea of how this works, I want to find, this is a long day. I'm just going to hop back to 0.0 so that we can talk about, we can envision that we have turned 0.1 into 0.0 through the power of renaming and typing. Yeah.
Just out of curiosity, how much does it cost to host pwn.college every day?
So ASU owns the servers that we run it on. So we're good there. It's just whatever the upfront cost of the servers are, which I'm sure was not a small sum. Okay. So since you guys have already dealt with a lot of this, somewhere in here is a check, right? Because it's doing some type of mangling, and then there is the comparison on whether or not we start printing out. It's right here. It's going to be. So my thought, and again, I don't know this because I've been looking at this for the first time live with you here, not literally, but as far as recent times are concerned, I want to claim this right here is where the comparison starts. I don't know that it's the case. Do you want to correct me? You can. I'm totally possible of being wrong.
Not particularly. I just think that V2 right there is the start normally, but no, because the immediate thing followed by the LT is the start. So you're right.
Okay, so we think I'm right, and I don't know this because of secret knowledge, right? I haven't looked at these challenges in great detail in quite a while, but I think about how would I implement? Again, that is kind of your insider intuition as a reverse engineer. It's how would I implement this type of thing, right? There's going to be some input. I'm going to mess it up, and then I'm going to check the bytes. And we know Yon 85 works on individual bytes. If I'm going to compare a string, what will it probably look like running on this thing? There's going to be some comparison, and then we're going to conditionally do something, right? Which we see here. There's the comparison, and then we are like doing something. If, do something. Compare, if, do something. Where we're setting this V2. I would envision this V2 being the value at the very end that determines whether or not we succeeded or not. And so we see right there, this is our big check, is this V2. If V2, we do this one long series of output. And then on the other side, hopefully, we see the else if not. And so what we're trying to do is we're trying to make sure that V2 swings one way or the other. And that's just kind of like high-level reasoning about like how does this thing probably work? Like if I were to try and write this. And we see that V2 is influenced by these interpret compares. This is the part where GDB just kind of becomes OP. So if I was interested in these byte values, and I know I could GDB script here, and I could look at this comparison, what would I want to do? I already wrote a GDB script that broke at interpret immediate and printed out something pretty for me. Could I write a GDB script that breaks at this comparison?
Yes.
And would it print out stuff? Could I look at what is the expected value of things? So I'm gonna do that. This isn't going to get to the Python reversing, but it's just more fun. So I don't need this base. I'm breaking at interpret compare. See if I can spell. And what I'm interested in is, again, RSI RDX.
So I have a question.
Yes, question.
When you rename in IDA, does it transfer to
Okay, the question for Twitch was, when I rename something in IDA, does that transfer to the binary? The answer is no. IDA does persist this information if we like file save. That's why when you first open something up, IDA starts complaining about saving something to challenge. IDA saves them, which turns into a bunch of garbage here. There's going to be all of this. This is all just IDA database, IDA's representation of the changes that we've made. So if I were to open up again, my changes would persist, but it does not change the actual binary. I actually had a conversation with someone, if you're interested in that, outside of the dojo. Let's see, if I cite github.com binsync. So this is a project that is maintained by somebody in our CEFCOM lab here at ASU. It's called binsync, and what binsync does is exactly what you're describing. Binsync synchronizes the symbols from a decompiler to GDB. It's not actually changing the binary as far as I know. I could be wrong there. But it synchronizes your types, it synchronizes the symbols, so you can start making changes in your decompiler, and then you can see the decompilation inside of GDB as if you had source. It's a super cool tool. And I actually considered and had a discussion about possibly bringing this into the dojo as something that you guys could use and play around with. Unfortunately, there are just realities as far as like cost. binsync itself is free and open source, but to perform that synchronization on Binary Ninja requires a paid version because you have to be able to use the scripting portion of Binary Ninja. Similar IDA, you can't get that tie-in unless you have a paid version of IDA. And so we can't be giving away paid versions of software, right, for free on the internet. That would be a no-no. And so if we were to have this would only work with, I think, Anger and Ghidra. And I don't know if anyone has tried to use either of those tools, but if you're first learning how to use a decompiler, it's a lot more terse output until you're familiar with the tool. Just because you hit tab and you're going to get really nasty looking decompilation. And so we didn't pull this tool in for that reason, because then I'd be telling you to use a tool that is just fundamentally harder to understand. But if you are interested in doing that in your own workflow, I definitely check out this project because it does exactly that. Twitch, no comment. Binsync's awesome, guys. Okay. Where was I? What was I doing? Oh, yes. We're trying to set this breakpoint at interpret compare. And that's why I default to having that just base constant and copying the binary. Because like that is universal. So I'm trying to set a breakpoint here at interpret compare. And what I'm interested in are what are the two values that are being compared. And what we see is that is not in RDI and RSI, is it? It is an RDI and RSI. That's just the pretty version being printed. So I could pretty much reuse this same thing, right? Uh-oh. What did I do? Oh, CMP. I'm doing the same thing, using the challenge binary instead of do.gdb temp. I didn't copy it. Do I get my pretty output? Here's my breakpoint. And here, what I'm actually printing is the encoding of the register. So I'm not actually printing what I want. Right? If we look at the implementation, it's not actually comparing. My output was like 4 and 1. Where was it? calling interpret compare for 1. These are not the values being compared, right? I had a false assumption there that it was the literal value being passed into the function, right? It'd be pretty silly if it was 4, 1, 4, 1, 4, 1, right? We're not comparing 4 and 1, right? How do I fix that? Yeah, we have the pretty IDA. Okay, so the statement was inside GDB, so inside my GDB script, I could use something like XGX. XGX doesn't work well in scripting. In general, you have to use P, and then if you wanted to do the equivalent, you do something like P star long star or RDI. Like this would be the equivalent of examining one giant hex at RDI. And then if you are super cool, this is a common pattern, this like star cast. There's actually a shorthand for it where you use the squiggly instead. And that is the equivalent of casting and dereferencing. But until you know that, I would, like, until you're more comfortable with GDB, I feel this is a lot more clear to read and understand. So I could do this, but is that really what I want to do? Let's think about that. What is in RDI and RDX? It's going to be the 1 and 4 that I had. If I were to try and dereference 4, that's not going to end well. Right? I'm going to seg fault. So I need to think about, okay, this is the emulator, right? That just has in RSI and RDX these constants that are the encoding. How do I get the actual value that is there?
Go to the struct register and see what memory it's actually referencing when it goes.
Okay, so that's a cool solution. And I like it. The statement for Twitch was, okay, well, I could go and look at the memory. One of the things that we saw earlier here was this first argument was this like yon struct thing, right? And the registers are represented somewhere in memory. And so I could rely on RDI and then look at like RDI plus 256. That's going to be one of the literal register values that's there. I don't know which one, we'd have to figure it out, but it's not going to be that hard because how do you think these numbers, these like weird number encodings I have, relate to how it's getting it? Well, if we go into like read register here, A 256 is if case 4. And so now I know that this is, if it's 4, I can grab my yon struct pointer and then grab reg 1, right? We could do that. And that's a very cool way of doing it because now you have a deeper understanding of how the emulator works, right? You're starting to think about inside the implementation of the emulator, how is memory laid out? The other thing that you could do, which is the lazy solution, is somehow in interpret compare, it has to get it, right? It has to pull in these values and do the comparison itself. Now, here we have the benefit of we have the benefit of the symbol. So we see read register, and this is going into V7 and V8. What are V7 and V8?
Those are actual values.
I'm sorry?
Those are literal values.
They're where the literal values are going, right? This read register function is grabbing it from the memory location that is the register, the implementation of the register, and then returning that value. Would I find V7 or V8? Can I just print it in GDB? Like, where is this in the process's memory?
Stack.
Why?
It's a function.
Okay. The answer was it'll be on the stack, and that's correct. The reason that it'll be on the stack is because we're inside a function, and these are local variables, right? These are being declared inside the function frame. Local variables are on the stack, and then IDA does also tell us right here where it is, which is also pretty helpful. But at a conceptual level, they're local variables, so they should be on the stack. So this is at RSP plus 1E, RSP plus 1F. So let's see if I can get that. We're going to set, get rid of this nonsense, arg1 to be RSP. We want to cast this as a, I'm going to go for a char pointer. Oh, wait. Let's see if Twitch is right here. They just use the fancy uint8t. Make it a uint8t star. And we said RSP plus 1E. And then the other one was RSP plus 1F. All right, who believes in Twitch chat? Nobody. They're all doubters, Twitch. Let's go up here. Where's my compares? What did I do? I did do do.py. That's what happens when you name everything do. Did I do challenge again? No. Let's see. Interpret compare. Commands. Run. No arg1. Oh! Yeah, that one wasn't Twitch chat's fault. That was mine. Did we get it? Calling interpret compare 0, 0, 0, 0, 0, 0. I'm not a believer. What did we do? Char star RSP plus. So I probably don't want to break at interpret compare itself, do I? Because that's going to be up here at the entry point of this. So when we say break at the function, GDB more than likely is going to be right here after the function prologue, right? So it's shifted the stack, but we haven't actually put the value there yet. And so I want to go a little bit further. I want to go after the calls to read register. So it should be right here, which is interpret compare plus 74. What do we do? Okay. So my char star, maybe uint8 whatever was the right type. But we're starting to see something that looks a little bit more sane. And so we could utilize this to just, the part that I care about is this comparison. And so I could print out what are the literal bytes that are being compared. I could play around with my input and see how that is influencing these comparisons. I've only got about 5 minutes or so left. Does anyone have any questions about anything I ran through here? Or something that you're like, hey, hit this now. Why did I talk about 17? But both are valid. If you don't tell me on Discord, hey man, 19, 19, 19, you're going to get whatever I come up with. Yeah, yes, sir.
What did you say was the difference between uint8
and char star? So they're both, in theory, they both should be 8 bytes. Okay. One of, what is it, uint8t. The problem is, and this is like a really goofy thing to say, you can have signed characters in C. It makes no sense. I 100% agree, but it is a thing.
What does that actually mean?
So it has to do with, remember, everything is bytes. Bytes are truth, right? I can print or examine the giant hex that's at RSP, whatever it's here. Okay, I could print as a char star and dereference it. That is now -57, which is C7. C7 is the literal byte. Well, what if I made it an unsigned char? Let's see if. Well, now it's. Okay, that actually worked the same way. Because this didn't have. That's to do with how you know how two's complement works.
Yeah.
Okay, so the highest order bit influences, if we print it as unsigned, how we're going to interpret that value. It doesn't change what the actual byte is, but it'll change how GDB or C or a program decides to interpret it. So if it thinks it's a signed char, it doesn't change the literal byte, but it'll think about it numerically differently, which is silly because chars are chars, right? But you can in fact add literal characters in C. It's the equivalent of adding bytes.
So they're the same mod 256, basically. Like the negative and the positive.
The statement is, so they're the same mod 256, and the answer, as far as I'm aware, is yes. But you can get some weird behavior there. That's why, in general, my default, if I'm going to start printing stuff out, is to just make everything a long star, because then it's 8 bytes. I will deal with in my own head, interpreting those bytes how I see fit. Did that give us something pretty? Oh, it gave us something. All right. Now, this doesn't make a lot of sense how I'm getting different values. I gave it a couple A's, but there's probably some type of manipulation going on earlier in it, right? And likewise, I don't know if this other value is like seated on the flag. Somebody's nodding, so maybe, which is why I'm getting null bytes here and here. Because if I'm trying to open the flag and then read from it, it would get nothing, which could be what's causing my null here. We can actually reason about that real quick. As long as we have the time, we can sudo do.gdb. See if my ramble there was correct. My ramble was not correct. So there's probably something else off here in the GDB script. What did I do? 1E, 1F, 1E, 1F, arg1, arg2. Does it format strings again? Yeah. So I'm not sure what I'm off there, but you could totally see that working if I found out what my issue was here for live demos.
Right.
Question?
Something like I don't know if I can really trust what IDA is showing me there, because stack is dynamic. So
The statement is, I don't know that I can trust IDA right here. So I am very distrustful of decompilation tools in general. I don't think IDA is going to get the stack location wrong. The statement from the class was that the stack is dynamic, and that is true in the sense that the stack grows and shrinks as the program is running, but the stack is, generally speaking, deterministic in the sense that within a function frame, you have to know the offset from RSP or RBP, one or the other. There must be a constant to get to a particular local variable. Otherwise, just the CPU itself can't work, because that's how we refer to local variables, is relative to RSP or RBP. So I don't think IDA is getting that wrong. It could be, but I don't think it is. Let's see if Twitch caught my mistake. You can silently do GDB. Yeah, I don't care about that. Not today. Any other questions in the 2 minutes that I have? Yes.
You said this is also, you can do this in Python as well?
So what I wanted to do, you can do this in Python. If you go into on the Discord, I think it's in the on topic channel. Somebody asked something about dynamic scripting in GDB. In the example I threw up there, I wrote a Pwn tool script that used gdb.debug.
Okay.
And then instead of having this be a separate file, the second argument to gdb.debug can be GDB commands.
It's basically the same.
Yeah. No, so all of these tools do the exact same thing.
Right.
It's just a matter of like how you want to do it.
The only advantage is like you could programmatically like send bytes in Python.
So
easily.
yeah, so the question was like, what's the advantage of one or the other? Why would you? So my workflow would be to do it in Python.
Okay.
And the reason for that is I could then debug my payload dynamically as I'm developing it, as you mentioned. Now that doesn't mean, like if I echo hello into my file here, and I go back to GDB, I can run and then direct in my file into standard in here. So I'm just run less than my file. And so I can still use GDB on the terminal and have it take in input, but that has now increased my feedback loop opposed to just doing it all in Python.
Okay.
All right. Cool. If Twitch has nothing else, I'm going to call it there. I appreciate y'all. Goodbye and good luck.